So this is the homework for the KW, pH, POH little lesson that we did. And this is basically going to be about whether you can calculate H3O plus, OH minus, pH, and POH given one of those values. All of them are linked from our formulas. We know our negative log of concentration is our power, and to go from power of H or power of OH to back to our concentration, we have to do 10 to the power of negative whatever value we have. So they're just reversible. We know that pH plus POH is 14, and H3O plus times OH minus is 1 times 10 to the power negative 14. And using these formulas, we can basically go anywhere. Hydrochloric acid, 0.45 moles. So this is a strong acid. So we know our concentration of H3O plus is also going to be 0.45. Our concentration of OH minus, I'm going to do that up here, will then proceed to be KW divided by H3O plus concentration. Maybe if I write, there we go, 1 times 10 to the power of negative 14 divided by 0.45, which is, very small, going to be equal to 2.22 times 10 to the power of negative 14. And does this make sense? Well, yes, it does, because we have a hydrochloric acid. You expect the OH minus concentration to be super, super small. Right, so let's do another one. Calcium hydroxide, 1.1 mole per liter. So here we know our sodium hydroxide. Sodium hydroxide, not calcium hydroxide. So our concentration of OH minus is the same as our concentration of sodium hydroxide base, which is 1.1 moles per liter. Our concentration of acid, or H3O plus, is again going to be equal to KW divided by OH minus concentration, which is 1 times 10 to the power of negative 14 divided by 1.1, which is equal to 9.09 times 10 to the power of negative 15. This makes sense. I have a sodium hydroxide solution, and I have a concentration of H3O plus, which is super small. Okay, we're good. We're going to speed things up a little bit. So hydrobromic acid is the same idea. Strong acid. All of it dissociates, so I have 0.95 molar hydrobromic acid, 0.95 molar H3O plus. KW, 1 times 10 to the power negative 14 divided by 0.95 OH minus concentration of 1.05 times 10 to the power negative 14. This one's a bit more interesting. Calcium hydroxide. We have to remember that 1 mole of calcium hydroxide dissociates, well, completely. I'm going to put two arrows, like just a single arrow, because it's a strong base, into two OH minus ions are given out. So the concentration of OH minus ions is double the concentration of calcium hydroxide. So we start with concentration of OH equals 0.01024. So concentration of H3O plus is 1 times 10 to the power negative 14 divided by 0.024, which is 4.1217 times 10 to the power of negative 13. Which makes sense. We have calcium hydroxide, which is a strong base. We have a super small H3O plus and a relatively bigger OH minus. Right, so OH minus is given here, so we can calculate our H3O plus concentration by doing, again, 1 times 10 to the power negative 14 divided by 5.6 times 10 to the power negative 14, which is our OH minus. We get 0.178, which again is equal to our concentration of HCl because it was a strong acid. So the concentration of HCl was equal to the concentration of H3O plus. So that was easy. H3O plus, molar concentration of calcium hydroxide. This is a reverse, the exact opposite of what we did. First we calculate OH minus by doing Kw divided by H3O plus, which is 1 times 10 to the power of negative 14 divided by 1.7 times 10 to the power of negative 14, which is 0.588. 0.588, which is then the concentration of OH minus, but then we have to divide that by 2 to get our concentration of calcium hydroxide. Again, because if we go back to our balanced equation that we wrote here, 2 OH minus gives us 1 calcium hydroxide. So we divide it by 2, right? So 0.588 OH minus will give us 0.294 moles per liter molar calcium hydroxide. Right, so that was this homework. Now we have a little more homework with the pH and pOH. So we already know how to calculate OH minus. We do Kw divided by that. And the new thing here is to calculate pH. So this is also not that complicated. pH is just, well, if you know the formula, it's not that complicated. You just sort of put it in your calculator. So negative log of 3.98 times 10 to the power of negative 7 gives us 6.4. So I can go two ways about this. If I want to calculate OH minus, I can just do, again, Kw divided by my H3O plus. Alternatively, from here I could find my pOH, which was 14 minus 6.4. Which is 7.6. I think I rounded a bit, but whoops. And so 10 to the power of negative pOH is going to give me my OH minus. I'm doing the long way just to show you all the formulas. So I do 10 to the power. Whoops. Which was 2.5 times 10 to the power of negative 8. Now I might have rounded that a bit, my apologies, but more or less that should give you, and if you do, 1 times 10 to the power of negative 14 divided by 3.98 times 10 to the power of negative 7, hopefully we get around the same answer, 2.51 times 10 to the power of negative 8. There we go. So it's the same answer. pH of 11.9. Where's the pOH and OH minus? So pOH equals 14 minus pH. 14 minus 11.9, which is equal to 2.1. So our OH minus is 10 to the power of negative POH. So 10 to the power of negative 2.1 is 7.9 times 10 to the power of negative 3. Again, we'll stress the fact that the low POH implies there's a high OH minus concentration relative to neutral, right? So our H3O plus concentration is going to be super low, our pH is going to be super high, and that all means that it's a basic solution, which we know is ammonia is basic. pH of 4.72 is phenol acidic, neutral or basic. pH is low, acidic solution. Super easy. Calculate everything. Okay, so first we'll do, what is the value? 4.72. Okay, so first we'll do H3O plus, I think. 10 to the power of negative 4.72, which is 10 to the power of negative 4.72, gives us 1.9 times 10 to the power of negative 5. We go from here to, what do we just calculate? H3O plus. We can calculate OH minus by doing KW divided by whatever answer we just got. 1 times 10 to the power of negative 14 divided by that is 5.24 times 10 to the power of negative 10. And we can calculate POH by doing negative log of whatever answer we just got for OH minus concentration, which was negative log 9.28. Boom. Okay, so see how we just do everything. Everything's connected. You can go from one place to another very easily, right? pH, POH, H3O plus, OH minus. It's all just using the formulas. This is a bit of a different question. The KW was given to be 2.5. So because we're not at room temperature anymore, not at 25 degrees Celsius, this is given to be the KW. And this is always now our new product of our H3O plus and our OH minus. So we have to calculate basically the H3O plus and the OH minus at, but I mean, this is for a neutral solution, right? So we're going to say neutral solution, we have to calculate H3O plus and OH minus. And here we'll say if one of them is X, the other one's also X, because they are both the same in a neutral solution. And we just do square root of 2.5 times 10 to the power of negative 14, which is up 1.5 times 10 to the power of negative 7. And that is equal to both the H3O plus concentration and the OH minus concentration. So both of those are equal to that number, and it's a neutral solution. Alright, so hope this helped. See everybody in class.